part 2 of 2.12. So question 214, the graph at the right shows a linear model for a tile pattern. How is the line growing? And that is how many tiles are added each time the figure number is increased by 1. So explain how you found your answer. All right, so we're looking right there. Number of tiles again is our y-axis, and then we have the figure number is in our x-axis. So here we're looking at this triangle right here that has pretty much, they're telling us that we moved 3 to the right, and then we're going up by 27 when we move 3 to the right. And the question is asking us, how much would it be if we only move 1 to the right? Like if we start off here, and then we go 1 to the right, and then 1 up. So here, if you notice, we can do a ratio to compare these two values. So 27 divided by 3, right? So that would be like the height of our triangle divided by the base of our triangle. And then if we want to figure out, right, how much do we go by 1? So here, 3 divided by what gives you 1? So in this case happens to be 3, right? So that gives us 1. And then 27 divided by 3 gives us 9. So we can say that every time we go up or we increase the figure number by 1, we add 9 tiles. All right, and then we're going to see what this relationship is. So pretty much like every time you guys see something in this form, like it's what we call a division, a ratio, right? So we want to simplify that, and actually these two are what we call equivalent fractions. So question 215, the triangles drawn on the graphs in part B of problem 213 and problems 214 are called slope triangles. So if you guys notice right here, that little one right there, 1 and 12, that's our slope triangle. And then if you notice, I kind of also drew them when we're doing parts A and C as well. And then here they give you guys another one, right? This is another slope triangle. Now let's start filling in the blanks right here. So if you notice, slope is the measure of the steepness of a line. So steepness. And then it is the ratio of the vertical distance. So it is the ratio of the vertical distance to the horizontal distance of a slope triangle. The vertical distance of the triangle is called delta y. All right, and this is also referred to as the change in y. And that's, if you guys remember from our learning target, it had those words in there. So every time you guys see the little triangle next to a letter represents change. All right, it's called delta, Greek letter delta. While the horizontal distance of the triangle, so if we're talking about the horizontal distance, meaning left to right, those are our x values, so we call it delta x. All right, so again, that one is said, that's called the change in x. So again, what is the vertical distance, delta y, the change in y for this slope triangle? So if you guys go ahead and then start counting, right, you'll notice that we're increasing by 2 in this case. So delta y equals 2. Delta x, the horizontal distance. Again, you start counting, you go 1, 2, 3, 4. Happens to be 4. And then they want us to calculate the slope of this line. So the word ratio, every time you guys see that word, that pretty much means a division. We're comparing two values. So we're looking at the ratio between delta y and delta x, just like we did in the previous problem. So this one happens to be 2 over 4. And then this is a fraction. So the best thing you guys can do here is pretty much simplify that. And that would give us 1/2. All right. And you'll notice too, like we'll go 2 to the right here and then go 1 up, right? Now it says draw several smaller triangles for this line that have a horizontal distance of 1. All right. So let's do it a different color. I'm doing in blue. So there's 1. It says use one of the small triangles to calculate the slope of this line. So All right. So if you notice, again, we already found the slope of this line is you guys go 2 to the right and then 1 up, or in this case, 1 up and then 2 to the right. So we can say delta y or delta x, right, which is the slope of this line, the steepness of this line, equals 1 over 2. And then we want to find the equation, right? So remember, the slope is actually the growth rate. So here, this one, every time we go up by 1, it increases by a half. So that's our growth rate. And then you can also figure out what the initial value, starting value is. And then you guys can figure out the equation. So that's going to be y equals 1/2 times x and then plus 2. And then our last question, 216, calculate the slope using slope triangles A and B. And then what do you notice? So first, let's find what's the slope for A and B. Again, it's always going to be delta y, the change in y over the change in x. All right. For some of you guys, you may have heard this as rise over run. All right. Remember, it's always going to be rise over run, never backwards, always rise over run. So here, if you notice for A, we have 6, that's our rise, so 6. And then our run is 4, so 6 over 4, right? And then we're going to look at so that's for slope A. And then slope B, we go 3 up and then 2 to the right, so 3 up, 2 to the right. So slope B, again, delta y over delta x is 3 over 2. And then what do you guys notice? So again, if you already noticed, these two are actually, again, equivalent fractions. 6 over 4 is the same as 3 over 2. All right. If you divide both the numerator and denominator by 2, you get the simplified version of that fraction, which is 3/2. Now for question B, what is the vertical distance delta y of triangle C? So this is for triangle C. So we have 4 there, right? Okay. And then again, it's just pretty much just the change in y, right? It's the change in the y values. All right. It says draw a slope triangle on the line horizontal with a horizontal length of 1 unit. And then it says, well, I'm sorry. No, that's not the answer for B. The answer for B, so they're telling us that this is 3 at the bottom. They didn't tell us. It looks like I misread that. It looks like it's 4, but actually, if you notice right there, the line has a little gap. So it's a little bit extra. So in order for us to find that, we just set up our ratio. So 3 over 2 equals delta y over 3. So if you guys remember from previous years, this is like the butterfly, you cross multiply. Right? You don't have to multiply the 2 times delta y, but usually that's how you solve it. You just want to leave delta y by itself. So here, in this case, it's going to be 3 times 3, it's 9 over 2. And then again, we know that because we use the ratios, right? So by using equivalent ratios. All right. So now we can do question C. Draw a slope triangle on the line with horizontal length of delta x of 1. Right? So 1, and then here. So it says, what do you notice? So again, it doesn't like necessarily cross it, right? So we can say that the delta y is about a little bit more than 1, right? So it's closer to 2. It's closer to delta y is closer to 2. So that's approximately 2. Again, it doesn't cross. If you guys look at it right there, it doesn't cross like an easy point right there, right? It doesn't cross uh, any part of the grid, or it doesn't cross part of the grid. The grid is there to help you guys read it a little bit better. So what happens to the slope when the slope triangles are different sizes? So if you guys have noticed, the slope remains the same. So the slope doesn't change. Right? This is very important because, again, that's the consistency of you guys having a linear graph, that it's always going to be increasing by the same amounts no matter where you're at in that part of the graph. So that's very important. The slope doesn't change even though we have different slope triangles. Different size slope triangles.